Hey, Andrew Skoog here, Machinist X. This is the Ask Andrew Friday. Every Friday at 10 o'clock in the morning, I take the questions that have come in during the week, I pick the good ones, and answer them here with my take. That's it. Let's get after it. So the question came into the Ask Andrew portal on a guy that asked a question about being a manual machinist. He does repair work, and he's wondering if he should get a D-vibe or carbide boring bar. He does a lot of pump housings and stuff like that, repair work, and wonders if he can justify having more expensive tooling to eliminate chatter, because he gets a fair amount of chatter. And there's a little bit more to it than that. It's not always the tool. He said he's made more rigid setups and put anti-vibe stuff on the parts to kind of dampen vibration that's happening. But a lot of times that chatter can be coming from the actual cutting tool itself, not always from the actual setup. And it can be from the depth of cut or the nose radius on the particular insert. But there's so many variables on where the chatter is coming from. If it's coming from the cutting tool, then there's a chance that a D-vibe bar would work. But again, it depends on the diameter of the boring bar. I don't know what diameter boring bars he's using. I don't know the size of the tooling that he's got. I don't know the size of the parts. I imagine they're relatively large, being from a scale of, large being, I imagine a pump housing being, 24 inches or something like that, or maybe even larger. But again, I don't know the size of these parts. All I know is what he's asking. And he runs an engine lathe, a relatively large engine lathe. It's difficult to know how large of a shank he's using on these boring bars and how deep he's going. All I know is that he's tried everything under the sun to get rid of the vibration. He has not run D-vibe or carbide boring bars. Everything has been steel so far. So with that comes the part itself. If the part itself is vibrating, that's not necessarily going to be shut off by a D-vibe bar. It will help, but if the wall is relatively thin and you get a vibration going inside the part, generally you got to try and shut off that chatter inside or on the part itself. You got to figure out how to suck that vibration out. The D-vibe bar will help for sure, because it's reducing the resonance or canceling out the resonance inside the bar, and it will definitely help. But then you have to look at the nose radius of the insert. If he's taking just a small depth of cut, say it's a 5 thou depth of cut with a 30 thousandths radius, that in itself is going to generate chatter. And then he said he runs 316 stainless, 410 stainless, nitronic 60. All of those are work hardening materials, and it could be that the surface itself is glazed already. It could be hardened already, and he's trying to skim a finish off of there. And you got to go to a really small nose radius in order to accommodate a very shallow depth of cut. And he doesn't mention any depth of cut in it, but I'm imagining if he's doing rework or repair, it could be some weld, it could be just skimming a surface to put another ring in, it could be hogging some material out, but generally the chatter is coming from a finish. He said he's struggling to get a good finish, so he's probably finishing this part, and I'm guessing he's using too large of a nose radius with too small of a depth of cut and a really small feed to get a good finish. All of those are going to generate a resonance because of the deflection that's happening. So you have to reduce the cutting force on the actual insert itself and get rid of the vibration by reducing that cutting force. And then along with that, chattering and the nose radius is small, then it could be just simply the angle of the insert in the cut. He might be a little bit above center. Generally speaking, on a bore, you want to be a little bit below center of rotation and have a little bit of a negative angle attack to it so that the pressure goes into the cut in the proper way. If it's too positive, generally it's going to chatter because the bar is going to bounce. So there's a few things that you can do to adjust the bar itself to get rid of chatter, but my suspicion is that it's the nose radius is getting to him, and then a ground versus a molded insert. I would run a ground insert in this situation with a small nose radius, and then again, it could be the angle of the insert itself going into the cut. So there's a few different things that can happen here, but my overall feeling on this is a D-vibe bar is definitely going to help, or a carbide bar is definitely going to help if the rigidity is the issue. If rigidity is not an issue, then I can't see where a D-vibe bar is going to help, or a carbide bar. So if it's, if you're beyond 4 times D with steel, then a carbide bar is going to help. If you're beyond, say, 6 times times D with a carbide boring bar, then definitely a D-vibe bar is going to help. But it's so subjective. And also, I'm not sure if he's running a tool post on this machine. A lot of those tool posts are a dovetail type system, and those dovetail type systems do wear if it's older, and so the vibration could actually be coming from the tool post. We don't know, but I would check the solid rigidity of not only the part but the work holding side, and then get the biggest bar I can and the most beefy holder I can to absorb the vibration in the cut itself. Once you have a very rigid setup, then it's time to look at the cutting tool from a nose radius perspective, and from a ground perspective, and from a positive or negative perspective. You got so many variables on the cutting tool itself. So my first objective would be to understand the depth of cut. The depth of cut is going to tell me what insert to run and what nose radius to run. And the material is going to tell me if I want to be negative or positive. And in the stainless tools, I'm going to want to run a positive natured cutting tool because of the work hardening aspect. Then I'd also want to understand what the material surface is like. If it's already glazed and hardened, then of course the insert itself has to have the ability to cut through that hardened layer. And so you look at the material is going to dictate the insert, the depth of cut is going to dictate the insert. The rigidity is going to depend on whether you want a D-vibe bar or if you want a resonance picked up inside the part. On a thin wall part, you can wrap it with D-vibe material, lead-based materials manufacturers out there that actually have pads that are able to go on the part to suck up the chatter in the actual setup. But you have to understand where that chatter is coming from, if it's coming from the part or from the setup. Anyway, so the material and the setup are going to dictate the cutting tool itself and the bar. So the question again being challenging with not having all the background information. These are some things that in my mind, when I'm looking at a setup, I want to understand where that chatter is coming from first of all, and then the material is going to dictate what the cutting tool situation is. So it's kind of a roundabout way of saying I don't have enough information yet to determine if you should run a D-vibe bar, but the D-vibe bars are phenomenal for especially deep hole type applications, because the deeper you go with any kind of a cutting tool, the more chance there is of having vibration. And in a pump housing, I can't imagine that if they're super deep cuts. They're probably large diameter and thin wall and relatively shallow but maybe contoured. So in my mind, I'm trying to think how I could be helping him with getting rid of the chatter. So the question of having the spending money on the tooling, I would say that you would want to spend money if the tooling is going to help reduce the chatter. D-vibe bars are worth their weight in gold. So it's not only for a CNC environment. In fact, when I went to see a shop that had a D-vibe bar, they had a 1-inch bar sticking out 12 inches. I was actually kind of wondering if he's going to break that thing off when we hit the part, because he was taking about 100,000 depth of cut. And I watched that D-vibe bar just bend, but it didn't chatter at all. It was silent as ever. So I know that the D-vibe bars work very well. I've seen them in action in many different applications. It's just they have their place, and if you get a large one, say a 2-inch bar, you're going to be spending a lot of money on something. You get a 2-inch 10XD, you're sticking out 20 inches, and I don't imagine that he needs to stick that far out. But again, not knowing the application, D-vibe bars are phenomenal in the application they're designed for. So don't worry about if it's a CNC environment or a manual environment. The vibration is the same regardless of what kind of machine you're in. So look at your setup first, look at the material second, and then get your cutting tool in line with the whole thing. And that's the approach that I would take. So another question came in, and it's the gist of it is, how do I learn feeds and speeds when I'm doing one-offs? And the actual question is, I hear you say feed and speed is important and it's a dying art, and you talk about writing your numbers down. But if I'm doing one-offs or a new part or a different process every day, how do I keep that in line? How is it useful? Do I have to write everything down or just general stuff? And if I change the type, style, or brand of end mill, is it going to be different from another one anyway? When you say learning feeds and speeds, what does that mean to you exactly, and how do you go about about it. So the gist of the question is, how do I run feeds and speeds when we're doing one-offs? Now, the one-offs doesn't really matter. The feed and speed, how to generate feed and speed to get a good starting parameter. Well, if you don't have a good means of documenting what you're doing, the one-off, the part always changes, but the setups, the material doesn't change, the cutting tools don't change, so the variables themselves don't change, the setup does. So if you're not writing down what if you're cutting, say, 17/4 stainless with a 1/2-inch tool, and you don't jot that stuff down, what worked and what didn't, you're always starting over. So the catalogs always give you good document or good feed and speed, assuming that the part is rigid. You're less than 3XD and you got a solid setup and so on and so forth. They give you good starting parameters. From there, it's up to the machinist to figure out what worked in the actual setup. If he's at 4XD or 2XD or running a side cut with a 5 thou depth of cut versus a 250 thou depth of cut, and so on and so forth. So in order for a machinist to slowly figure this out in his mind or in his repertoire of situations, you have to, at some point in time, write stuff down and keep track of the actual application, like the material, the machine, whether it was a manual or CNC, what the nature of the cut was. Was it finishing? Was it roughing? What happened in the cut? Did the tool fail from a heat? Did it fail from chattered? What was the failure mode and how did I correct it? Like speed is the #1 killer of carbide tooling, and if it's run too hot, the tools fail. Or if you're rubbing, they fail in a different way. So if you're making dust, you have to be able to read your chip, and the chip is going to tell you what's going on in the cut. And so how do you learn feed and speed? It's through continuously running and documenting what's working, and also documenting what's not working, because if something didn't work and you come across this again, if you didn't document what failed or what challenges you had, how are you going to know how to start the next process? You're always going to be relearning. And so I don't document everything that happens in the cut. I document what worked and I document what didn't work. And so doing this for 30 some years has given me a very solid understanding on how to do stuff without having to think about it. It's kind of like walking into a door that's got a combination. You don't even think about doing the combination because you've done it so many times. And so the machining is no different than that. If you're running a material that you've never come across before, but it's similar to a material that you have cut, you kind of start with that parameters, but you have to understand, has it got more nickel in it? Does it have more titanium in it? Is it more iron based or more steel based? Is it more, there's so many different nuances of the machining itself, but if you never document it, how are you actually going to know how are you ever going to know how to actually start? I mean, again, book parameters are one thing, but the machine itself has some limitations as well. So if you're running in a CNC mill that's 30 years old versus one that's brand new, that's a nuance that changes also. And so your mind will always tell you, after you've done it for a while, what parameters are actually going to make a difference. Like you might have a machine that's only got 3,500 RPM and you're running a 1/4-inch end mill in a material that needs 10,000 RPM. So then how do you get the heat into the cut, and how do you approach this without making without getting a built-up edge, so to speak? Or there's so many different nuances. Do you have to go to a different coating in order to run in that particular machine? Or is the machine spindle just inherently have runout because it's all wore out? There's so many different things that come to the equation when you have experience and when you've been writing stuff down. Like I had a machine that had run out in the spindle, but I had some tool holders that weren't very good, and I could play with the particular tool holder and the spindle to get decent run out, to get straight walls in my pockets when I was mold making. So there's so many different things that happen, but you have to keep track of what works and what doesn't, because there's so many different nuances. Again, book parameters are one thing, but the reality is another. And I want to just say this, that nothing if you write nothing down, you get nothing out. If you write something down, you learn a little bit and you have a reference point. If you write more stuff down, you get confused. So there's a balance of writing what works and what doesn't, and the only way to do that is to get started. You either take out a pen or take your phone out and you have to have one place where you're keeping this stuff, because if you have notepads everywhere, you're going to be chasing it around and you're not going to know where it is. So have your own little spot where you write things down and have a reference point. You might separate it by a machine, you might separate it by material. I always separated it by material and operation. So if I was milling, and I would have a place for milling, and then I would have a place for the material. So there's multiple ways of keeping track of this, and so that's where I would go first, is jot down the material, jot down the operation, jot down the diameter, and jot down what worked and what challenges you had. If you were in a deep bore, for instance, write down how you got rid of chatter. Was it the nose radius? Was it feeding it harder? Was it going to a divide bar? Was it going to a ground insert, a molded insert, so on and so forth? You get the gist here. But after trial and error or talking to different people, you'll start seeing that people are recommending the same thing, or you'll find out that after doing this same operation or a similar operation 50 times over, you'll start to get a sense of what worked, and you'll shorten that learning process, or the time that it gets to get a good part. So I hope this helps. To summarize, there's part of the question here too that I think I missed. If I change the type or style or brand of end mill, is it going to be different from another one anyway? The answer is yes, it's going to be different. If you use a general purpose end mill once and you use a high performance tool next, say you're cutting hardened steel and you got a one-off, you're just going to grab a cheap end mill to get the part done, assuming it's a small operation. But if it's a long-running part, you're going to want to get a tool that's designed for that application. And then, of course, things change. But again, you document that. So an end mill made for hardened steel is going to have a much thicker core, because you need rigidity to battle the resistance of the cut. So use a tool that's made for the application. Don't just assume that a higher cost end mill is going to do a better job in a certain material, because I've seen cheap general purpose end mills outperform end mills made for an application. So there's many nuances there. But actually I had a situation where somebody was cutting 3/16 stainless using an end mill made for hardened steel, and their assumption was that because it's a $30 end mill versus a $5 end mill, the $30 end mill is going to perform better. Not the case, because a tool made for hardened steel has edge prep on it, and it is going to rub in stainless steel. It's not going to give you the good cut quality that you get out of a tool made for stainless. And general purpose end mills don't have any edge prep on them, so they work very well in stainless steel. Again, they're not going to give you longevity, but they'll give you a better cut than a tool made for hardened steel. So there's many different nuances here. And again, these are things that you get over time. And let's see, there was another part of it. When you say learning feeds and speeds, what does that mean to you exactly, and how do you go about it? So to reiterate, I look at the application, and then I already know what feed and speed that it should be run at. But if I don't, I'm going to reference a catalog, and then I'm going to look at the application and run from there. So feeds and speeds are a documented process learned over time. Reference a catalog, get your starting point, talk to reps if you need to get their take on it, and then the learning happens when you start cutting. Hopefully that helps, and we will see you on the next episode. So if you got a question on a setup, or need some advice, or got an application that's kind of bugging you, setup, whatever it might be, go to the machinists.com. There's a page on the website there where you can submit your questions, or you can just go right below in the description and click on a link, and that'll take you directly there. So put the questions there. I will let you know when I'm going to answer your question. Stay tuned to the channel. We get a lot of amazing questions, and yours might be one of them.